Kepler 442b, you say? Okie dokie, let's head over there. I'm not going to lie, it looks kind of promising, a lot better than Jaywick. So Kepler 442b is a near-Earth-sized exoplanet. It's 1,200 light years away from Earth, and it sits comfortably around its star's habitable zone. The habitable zone is an area around every single star where liquid water could exist. The planet is classed a super-Earth because it is slightly bigger and slightly heavier than Earth itself, which means the gravity is going to be slightly higher than what we experience here on Earth. As for its parent star, it's what we call a K-class star. It is slightly smaller and colder than our Sun, which is a G-class star. It's about 0.6 the size of our Sun. Size-wise, you're looking at about 6/10 the size of our Sun, with a surface temperature of 4.4 thousand Kelvin. In comparison, our Sun is 5.5 thousand Kelvin, so it's smaller and colder. Back to 442b. It orbits its host star at 0.49 astronomical units, or 38 million miles away from the Sun. In contrast, Earth orbits at 93 million miles, or 1 astronomical unit. So it's closer to its parent star than Earth is, but at the same time its parent star is colder and smaller, so it should be okay. And because it's closer, 1 year lasts about 112 Earth days. Nice short years, fantastic. And it is indeed one of the more promising candidates for habitable planets besides the Earth. As I said, because it's bigger, gravity is actually 30% stronger than the gravity on Earth, which is why my shoulders are starting to hurt a little bit. What about its temperature? As for temperature, the equilibrium temperature of this planet, which is the temperature of a planet that doesn't have an atmosphere and is purely heated by the energy it receives from its star, is minus 40 degrees Celsius. So if it turns out to not have an atmosphere, it's going to be pretty cold. And as a bonus factor, unlike the exoplanets we're finding around red dwarf stars, which are much smaller, this planet is just outside the zone where it would potentially become tidally locked to its star. For those of you who don't know, tidal locking is basically what the moon has with Earth. In the case of a lot of red dwarf stars, because they're much smaller and closer, most planets have the same side constantly baked in sunlight and the other side completely coated in darkness, which means one side of the planet will be scorching hot and the other side will be cold. But that's not the case for 442b, potentially, because it's just outside of that zone. Now for some bad news. Because it's just outside of this zone, there's a chance that its rotation will be very slow, comparable to Venus or Mercury's rotation perhaps. And unfortunately, with K-type stars and M-type stars, this is more the case with red dwarf stars, which are M-class. Unlike our Sun, which is relatively stable, these types of stars tend to be quite active, particularly at the beginning of their lives. And we're not quite sure how old this star is. At the beginning of their lives, they have ridiculously strong solar winds. Some of them can even have superflares, which obliterate the atmosphere of a planet sometimes. So there you have it, Kepler 442b. Perhaps the James Webb Telescope will be able to tell us more.